about sandy soil, let's say 30%, 32% of porosity, but I still have something inside, and therefore I only have part of it as a usable pore ratio. Why? Because I will never, with no injection, either if I use polymer or cement, either if I use water, I will never fill 100% of the pores. There is always some water which is bonded to the solids. We have always some porosity in the solids or in the granular itself, and therefore we calculate usually with 75 to 80% of filling degree. If you take into account 1 cubic meter of soil, yeah, you have 30% of porosity, so 300 liters, and 75 to 80% you can fill with your injection medium. Nothing more, nothing less. And if you really need then the final number for your budget, of course, that can be done in the second step after estimation based on the soil with a trial injection. So now I told you already that you have two types of soil, and you all know that. We have the cohesionless and the cohesive ones. So clay and silt is always critical to inject. And the other ones, depending on the fine content, depending on the grain size distribution, are better, or let's say, at least they are better to inject than clay. For these two different types of soil, there are also two different types of injection methods. It's on the one hand, the penetration routing, which is what I just explained. You displace with your injection resin or with your fluids, what you're pumping into the soil, you displace air and water. Very important, you will not displace the solids. You will not compact the soil, you will not lift, you will not do anything with the grains of the soil. You will just penetrate with a very, very low pressure to fill the pore system and to have in the end a hardened resin soil matrix. On the other hand, you have here this penetration, this displacement method. What is that? This method is not even aiming to get penetration. The only aim is I want to displace the soil around me, around the injection point, by expansion of the product, not by pressure of a pump or something, by expansion of the product itself. And what will happen in such situations is that by the pressure of the expansion, you will create lamellas and roots. Yeah? You somehow frack the soil. This way you can even go into clays and silt, so soils where you usually cannot do a normal injection, and laterally compact them. And then you have another interesting idea, which I will show you later on in our reference project. Let's say after compacting, after you try to widen your arms, soil is compacted around, and then there is only one way, and this is up. So you will be able also with this type of grouting, this displacement grouting with resins, to lift up structures, but not by pump pressure, just by expansion pressure of the resin. How to apply? So how to reach this point? Usually we have big drill rigs and things like that, so we need quite a good amount of machinery and equipment on site. So mobilization is a question, always. But here we are talking about quite easy stuff. First of all, it looks maybe familiar to you. You introduce somehow your injection pipe into the soil. You bring it down to the required depths. Let's say 5 meters, 10 meters, whatever you need. This method is good for up to 50 meters depth. So there is a limitation because of the application of these so-called injection ram lenses. Then, once you start the injection pump on top, then then the resin starts to flow, your so-called lost tip in the end of the pipe plops off, and you start to penetrate the soil from that point. After a certain time, after a certain amount of resin, or even after a certain pressure is reached, you can, during the injection process, you don't stop, you just lift up the remnants, so the pipe, to create pillars in the soil. And this is quite accurate. So if you calculate with 50 centimeters, for example, you can really accurately say, okay, you will need 23.55 liters per meter of this pipe. And then you can just calculate into your steps. To get an understanding how this method looks like and how the mobilization for such a job site looks like, you see here, you just use an electrical pneumatic jackhammer, push down 1 meter pieces of these pipes, steel pipes. Depending on the job and the depth you want to reach, it's between 1/4 and 3/4 inch. And this tool is a lifting tool. You can also use a jack rack or an excavator which is nearby. But the main idea is that you start the injection, and during the application, during the pumping of the resin, you lift it up. In the end, it looks a little bit like easy and slow jet grouting, but it isn't, because we are not mixing up, we are penetrating. And to have a real scale picture from a real job site, so you see this is the space requirement for such a measure. Here this was done in a city near to my hometown, Bochum, where they have a bus depot for public buses, and they wanted to create some area where they can go under the buses and repair them. So we had a requirement to stabilize the soil around, and in this area, in this garage, we could place the injection pump. This is the pump, some material which was required, and here on the side you see the steel pipes, the small steel pipes. These are the remnants, and you see you can work even if you have a low height, and you can also work with minimum damages of the existing structure. So we are talking about small, tiny drill holes. So let's come to the practical references to give you a little bit idea how such a job site works. First of all, the penetration method. This is, let's say, the easier injection job. But easy doesn't mean that it's not challenging for the equipment, for the material, and also for the application team. Here is one project which is from Belarus, and this was a soil consolidation of a very, very porous and soil without fine content. So they had tried to build up a new pedestrian tunnel for this metro project, and therefore they wanted to stabilize the soil. And the problem was, they pumped cement, because that was the first option, let's pump cement. And they pumped, after 25 tons of cement, they made some pilot drills, nothing. It was just flushed away. Why? Because there was a lot of groundwater flowing inside, there was a river nearby. So they came up with that idea of doing something different. And at that time I was on that job site as well, and explained, guys, let's try something else. Let's try something what we can control, where we can control the reaction time, where I can tell you, okay, the flowing way will be like 1 meter, like half a meter, like 2 meters, and it will be not washed out. So the task which they raised was, okay, I want one injection point which reached 2 meters diameter in my porous soil here, and I want to create something where I can excavate in. Because if I have too much strength, or if I use polyurethane resins, for example, I will not excavate. So it was also a question of what type of material to use. This was the structure which they created later, so you can now also guess that they already had success with that. And here is an international team from MC together with the guys from that metro job site on the site and preparing in horizontal this trial. Because they wanted, first of all, to see that this method works. And what we injected there was this so-called MC Inject GL95 acrylic resin, fluid like water, but you can control the point when it starts to gel. Their question, when I spoke about gel, they asked, okay, come on, I cannot excavate in gel. I need strength. I need something which is rigid. And I said, okay, come on, let's do the trial and you will decide if you can excavate or not. The good thing of this gel is you can control the reaction time from a few seconds to several minutes, and once this so-called gel point is reached, it gets from fluid, like 5 millipascal seconds, like water, to a jelly stage where it's not flushed away anymore. And here, this specimen, what you see here, is consolidated, glued together by this gel product. We proved this as well on the job site. Here you see the ram lens, which is horizontal into this soil, and then they started to excavate one injection point, 2 meters. Of course, we have here a little bit drop of material. Why? Because this was just loose soil, which was just placed on the top of the construction site there, so artificially, and therefore they calculated after the trial also with a little bit of drop of material. What did we do? We adjusted the reaction time a little bit shorter, did another trial, and everything was okay, and they went for the job site. By the way, they tried also with the excavator if they can dig through, because that was also important for them. Everything was good, and then they decided, let's go for that project. Here in horizontal direction, they installed these ram lenses. What you see here is a pneumatic pull device which pulls out these lenses directly. So you don't have to use an excavator, jackrack, something. Here that is automatic. You can adjust the steps, what it does, and just inject, 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 pull out. And this was the result after they opened the wall. And then they understood also, okay, if I'm talking about gel and I had a very, very porous soil with no fine content, very, very low angle of friction, so even no stability, and now I have something which is reliable, which is standing by itself, and where I can work in. Please don't get me wrong, but I didn't recommend to take this as a final support. But you see what this material, a jelly product, can do in the soil. And then I have to add, there are also other materials which are supposed to have strength, where you have in such a soil like 50, 60, even 70 MPa. But I think we all know that we don't want to excavate in soil which has 70 MPa. Then we get problems even with the biggest excavators. Because when we inject it, we are injecting polymers, then it's not easy to demolish them. The second point, or the second method and project what I want to show is a displacement grouting. And this is done or this was done last year for a water tank at this thermal power plant. Here, around these water tanks, there was one big problem. Yeah, there was a construction site where they thought, okay, let's not make some trenches here, let's use for our new pipes trenchless piping. Okay. Problem was that they didn't have really their slurries and their drilling under control, and they made a lot of loosening of the soil around, a lot of blowouts, and what happened? Of course, these tanks started to settle. Two of them, one had a major issue because one of them settled 18 centimeters on one side. And we are talking about a 600-ton construction, 2,000 cubic meters of volume. And now the question was, okay, how to get rid of this problem? First idea was, okay, we will go there with a compensation grouting and lift it up by cement. The problem was that this job site itself was not the only problem. They had also some weak layer of clay below this tank. This was the construction itself. So you see, you have here first of all 80 centimeters of concrete, then some screed layer of 10 centimeters, then we have a bedding of 300, and then we have consolidated stiff loam, but below we had semi-consolidated clay. By the way, so that you get an idea for the dimension, water tank was 16 meter diameter. What we did, first of all, okay, let's test the soil, and we did dynamic cone penetration tests to find out what is the actual problem, where do we have the loose zone. And we find out that in the depth of approximately 3 meters, there was the weak zone where we need to do a consolidation, a compaction. But 18 centimeters settlement, we cannot only do a compaction, we also have to lift up. Therefore, we planned an injection in 2 main steps, plus, which you will see later on, a third step to stabilize everything. The first step is what you see here in the red color, so 3 stages of injection horizons. And the second step, the yellow color, is in an angle below the tank, so that you can reach the area in between. So this first step here will give you somehow a limitation and a first compaction, and this step here will help you in the already consolidated soil to lift. This was a job site, so no big drill rig, no big silos for cement, nothing. Just, again, same equipment, steel pipes, a jackhammer, and what you see here is the horizontal thing, so the step 2. And here what you see in this picture is step 1, and they're using a jack rack. So they didn't use a pneumatic tool or something, they just said, okay, we modify this jack rack and use it to lift, to pull out the lands. Short video about that. Oh. Something wrong. What's that?
It's back.
Ah, it's back. Okay. Unfortunately, you only see not running pictures. Let's try again. Maybe I can go just through picture by picture. So here you see they have connected the injection pipe. Okay. video does what it wants to do. Here you see the other pipes, and the idea is just to have a very, very tiny space requirement, and also to do the job in a very, very simple way. If you see this project here with a complete tank, that was displacement routing. If you see the complete project here and with all its injection points in the first step, in the second step on one side, and here another step to get sure that there is no settlement, then we are talking about, let's say, 500 liters of resin. If you use different methods, you might use much, much more. Why? Because this resin is expanding with pressure, and we are talking about maybe 10 liters per cubic meter of soil of consumption to reach an area of from 1 point to 1 meter. So the success was, or the control of this method seems to be questionable, because you are pumping something which is expanding, and how to control. The main idea of it is that we have a product which reacts directly. So it's like you're pumping it, and it directly foams up and stops after 7 seconds. And usually on such job sites we work with a laser nivellement, and once you see in this first step that the laser starts to shake, to vibrate, you stop, because then you know, okay, my next liter will lift. And in the second step, here the purpose is to lift, and 18 centimeters, okay, you have a lot of time until you reach a critical point where you have to be careful. But in this step, the only way is up. Why? Because the soil around was already consolidated by the first step. So once the lifting was done to the initial level of the tank, they said, okay, we need to prove somehow that once you fill your tank with 2,000 cubic meters of water, it will not settle again. First of all, very important, we did again a cone penetration test. Question from the customer, from the owner was, okay, but you injected a lot of resin, I will just hammer on the resin and I will not see any result. And we explained to him, okay, you will see once you hit a resin lamella, but once you are through, you will see the soil below is also much, much higher consolidated than before. So we did it in a lot of points to prove it, and then in addition, he filled the tank to the maximum. So we had 600 tons of construction plus 2,000 cubic meters of water, and altogether this could be done without any additional settlement then. So it was proof that now the tank is in the right level, and it stays also if it's full. And the important thing is, we are not lifting by pressure of the pump. We are lifting only with the resin performance. That is very, very important at that point. So what are your benefits? Your benefits are, I think I talked about that already, but your benefits are you have a very easy to use method. You have just, let's make it simple, you have some steel pipes which you have to ram into the soil. You have a tiny injection pump where you get the training from us, or the applicator. And you have a two-component material which the pump sucks in and pumps into the soil. Of course, this sounds easy, but contractors need some expertise and experience with that. But it's no rocket science. The second thing is low space requirement. We cannot always build up a big drill rig and all our machinery, so sometimes this is the only option to work with. Fast realization means not only that you can work fast, of course this method is fast, but also the result is fast. We are not talking about days of final strengths, we are talking about minutes. Depending on the product, you have the success directly in the same hour, in the next half an hour. We have done jobs where they worked in their normal business, the owners of these structures worked in their normal business 1 hour later. Noise and vibration emissions. I told you the example from the hospital before. Low investment costs in comparison to drill rigs and so on. And fast mobilization, demobilization, even if you work, for example, somewhere in railway tunnels where you have to lift the foundation or this railway slab. Or you are working somewhere in downtown here where you can only work on your job site for a certain time. You are very fast because you just have to put away your tiny equipment. You have an adjustable system, not only in the reaction time, but also in the choice of material what you use. And this is permanent if you want. It can also be temporary if you have to excavate, but it is always what you want, what you want it to be. And last but not least, also very important nowadays, and I think it is also the right way to go this way. All these products, what we are proposing for applications into the soil, are environmentally friendly. That means they are compatible with soil and groundwater and will not harm the microorganisms and the quality of the water itself. So now, I think I've talked a lot. I have shown a lot. So my question to you is how MC can now support you. First of all, we have a customized and technical solutions and estimations what we can give to designers, what we prepare for our partners. So as this method is quite new to everyone, or to the most people, we help there with technical support and prepare all the technical documents for that. We have in our hand a book full of international reference projects, which we can also use to prove that this method works and to get the one or the other experience from other projects into the actual one. We have approved contractors. That means that we are not applying ourselves. I told that in the beginning, we are just manufacturing, but we train people, we train applicators to work with the pumps, to work with the resins, and to work with the equipment, and to do this job sites, and therefore we are also with our customers in the end on the job sites and to support them, let's say, to help with the first steps. And last but not least, we will be happy to supply some material in addition to our technical support. That is, I think, our main aim as well. So, how can I make you happy in addition to that? Just let me know your questions, your ideas. We can also try to sketch up a project here. Oh, there are questions. I didn't assume questions with such a big auditorium. Yes, please. Oh, okay.
Yes, my first question is that how much ground improvement in terms of percentage we can expect by this grouting?
How much?
I mean, how much percentage of ground improvement? I mean, in terms of strength, soil strength.
It's depending on the product, and it's depending on the soil. When you talk about this penetration grouting, for example, with a gel, you will not reach more than 0.8 MPa maximum. Yeah, but this is more than enough because you are gluing the solids together. For if you have just, let's say, temporary support, or you want to excavate inside, this is enough and sufficient. If you use different materials, you can reach up to 50, 60, 70 MPa depending on the material and depending on the soil. With this displacement grouting, it is not always easy to say. Again, here trial will help, but I can tell you that with this lifting resin, what it lifts, it can keep, because it lifts by own pressure, by own expansion pressure, and it will hold what it lifts. If you need specific data about the compaction of a clay, very simple. Take 1 meter of length or 2, push it in the clay, inject 2-3 liters of resin, dig it, and make a core, and you see it. Or even you can make it a little bit easier to make a cone penetration test in the injected area, and you will see how much it densifies and how much it improves it. But the penetration itself, penetration method, is really depending on soil and in combination with the type of resin which we choose. So in the end, if you tell us I want to reach this type of properties, we will help you to find the right material to get it.
The second question is, don't you think there is a chance of groundwater contamination when you do the groundwater?
I cannot understand you.
Hello, yeah, you can hear me now? Yeah, okay. The second question is that, don't you think there is a chance of groundwater contamination by this jet grouting?
Jet grouting is the other room. Here is polymer grouting.
Yeah.
No. I'm just joking. So it's that is what I told you. It's environmentally friendly. Why do I tell this? Because I'm sure we have in Europe we have a test for soil and groundwater, which is unique in the world. Maybe I don't know all the regulations here, so sorry if I said something wrong. But we have to test. If you want to apply something into the soil in Europe, especially in Germany, where I'm coming from, you have to prove your material in a test where you have a 50 centimeter sand column, 1 meter high, and it's closed and it's water filled. There is a circle, and you have they turn on the water with a flow rate of 5 liters per minute, and you have to inject fresh material into the sand column, and they will test the water on the outside of the column. They will test it before application, during the injection, so with the liquid material inside, and in the reacted status. So you have before, while the product still is curing, and the cured product, and there we have to prove that we will not produce some amines, that the TOC level is below a certain level and will reduce after 24 hours and so on. So all this is tested.
Okay.
And also, maybe interesting, potable water certificate you can also have. Just a comment from German point of view. Potable water certificate in Germany I can get with every product. Because potable water certification is done by formulation control and by specimens which I can cure in my laboratory and which I can put into water for a long time, and then I send it to the test institute, and they will put it in water again and say, okay, they are good. Yeah, because my water was contaminated before. So potable water is questionable. Soil and groundwater certification is, at least in Europe, what we are looking for, what every customer is also looking for.
Thank you.
Just a question. What kind of the soil you have been used in GTA? And you know the area, most of the subsurface soils consist of the glacier tier, which is something different from the regular alluvium material.
Yeah.
And what kind of project?
We had actually we had two projects, two bigger projects here. One was in Kitchener, where our customer Earth Boring is creating this new trunk sewer, and they put the shaft there, and before they went into the shaft with their micro TBM, they injected with our gel product, with this gel 95, with this blue one. They injected some sealing blocks outside the shaft to drive through and to work without any additional measures, sealing measures. So there we proved that we can penetrate, because that was very, very fine, sandy, silty, high clay content. And the other project was here directly in Toronto, Scarborough extension line, together with company Strabag and their injection team. We did the umbrella injection before the TBM started. Below, what is the street name? York Street? Shepherd. Yeah, so it's really not depending what kind of soil we have, we just have to know it. And then we can adjust our method. We are working on one project where we have clay soil, very high clay content, and there is only one method, that is displacement grouting with this expansion resin. And even if I use this expansion resins and create the lamellas inside the soil, I can excavate inside. I just have to calculate my injection points close by so that I can be sure that my lamellas are overlapping. That's it.
And the second question, you mentioned this material can be used for the temporary and the permanent condition. How do you distinguish, or how do you define between the temporary and the permanent?
Okay. Temporary is, for example, you want to stabilize the soil because you want to build some new structure. For example, just recent project example. Old sewer system, new shaft, they want to connect it. Okay, I have to do some soil improvement that I can dig from my shaft into this area where I want to connect it. There, it's temporary. Permanent, the most permanent solutions you will ever see you will get in tunnels, because they ask you for 150 years of lifetime for that product. And therefore, this is what I mean with permanent. So, if you go somewhere as a final support below foundations, like you have some settlements or you want to stabilize the foundation, underpin it, then it's permanent, and then you need a permanent solution which should last for at least 50 years or longer. And we have done a lot of different tests, aging tests and chemical resistance tests with products, which proved that depending on what type of product, between 100 and 150 years of lifetime, of the product lifetime you have. Yeah.
Hey, Reza from WSP. So I just have a question. That seems like very good material. I just want to know if you had any study about the using this material for the stabilization of the slopes or control of landslide or something like that.
Sorry, I missed the part. What do we have?
No, I just want to know if you actually had a study of using this material for stabilization of a slope or, for example, control of landslide.
Yeah, we have done projects, of course not here in Canada actually, but I can, if you find on the table my business card, so if you send me an email, I can send you some information later on.
Okay, thank you.
I have two questions. Thanks for your presentation first. Really interesting product. The first question is related to the previous one. When you are using the material for permanent design, do you consider the creeping behavior? Like this is made by polymer, and we know like geosynthetics, they always have the creeping behavior in 100 years. Like, have you ever done any test for that?
Yeah, we have done, especially with this displacement material, this where we lifted up the tank. They asked the same question, and we have done odometer tests, so settlement tests, and we proved that there is only 0.3% of relaxation after 100 years. So it's proved in several tests. Yeah.
Thank you. And I think this grouting is like watertight, right? Waterproof.
Waterproof, yeah.
Let's say if we have a kind of very coarse sand and very high water level, and if we want to excavate inside of it, so can we use this material to avoid dewatering?
That is actually what for example in Kitchener earth boring did. They wanted to avoid dewatering, and therefore they injected sealing blocks where they wanted to excavate, where they wanted to open the shafts, for example. You can, so on the one hand, you can use this method like all other methods which you know already. So if you want to make a ceiling wall somewhere, you can do it. The question is always when it is economically a good idea. Because you can imagine that the polymer is more expensive than a cement, and where cement works, and where you have easy access, and where you don't need to look on, where you don't have time pressure, and where you don't have special requirements, a conventional method can also work. But yes, you can use it, especially for coarse-grained soils. It's nice because you can stop the flowing as you want. So you can adjust 30 seconds, and then the material will stop flowing after 30 seconds from your injection point. And then it's all a question of what you want to achieve. Should it be a complete area which you want to inject, which you want to treat, or do you want to have somehow a wall inside the soil? Question of application.
Yeah, I actually have one question. So, do you have any projects or any testing to testify your durability? Like, say, for the freezing and thaw or drying and wetting because of seasonal water change?
We have different test certificates for durability, thaw, and I think, and also drying and getting wet again. Especially the last one. With dry cycles, it's important for the acrylic gels because they can dry out. But they dry out if I put it here on the table. In the soil, I have always some residual moisture. That's enough to hold the properties. But nevertheless, we tested that even if it's drying out and 500 times, it will have still the same shapes, the same volume, and the performance will be the same.
So the stress will be the same as...
It will be the same, and we have as I told before, for different products, we have certification from not from our labs but from universities where we did the tests. So neutral test certificates, which proves, depending on the product, up to 150 years of product lifetime.
Okay, thank you.
And if you need it, you will get it. Yeah. So then we provide the tests.
Hello, I have a question, and you may have covered it, I missed it, but have you done any applications where you're basically using injection to create a cutoff wall to, say, contain a contaminated plume of, you know, either chemical or salt water or even, you know, hydrocarbons?
We did. My colleagues in Brazil, they are quite active in this area because they are working very, very close with some mining companies there, and they are doing also these cutoff walls in two ways, either with this jelly product and also with a rigid one. Also here, they do usually smaller areas, yeah, just because of economic reasons. But yes, when it's critical and when they need some fast solution, yeah, then they go for this type of method also for cutoff walls. Yeah, it works, and really, I always surprised again that the calculation what we usually do is quite accurate to the real trials and to the real job site later on. So you can really say I create 50 centimeter columns. So you tell me, okay, I need 50 centimeter columns which have overlap, and then we can tell you that you will, for example, use 25 liters of resin, which is too much at that point because 23.55 would be accurate for sandy soil. I know that so exactly because I just recently discussed a project in Israel with one customer, exactly the same topic. So and he just gave me a call and also wrote me an email that he was surprised because they did a trial on site in the soil and they digged it out and it was 50 centimeters. And as expected, they just said, okay, we reduced a little bit from 25 to 23.55 liters the consumption. Okay, good for you.
I have two questions. First is how much pressure do you apply in comparing with the cement? It's different, maximum pressure in the grouting.
If we are doing penetration grouting, we usually have very, very low pressure, below 10 bars. Of course, the bigger the shape of your injection area will be, and the bigger the influence area will be, the more pressure you will need at your pump. But outside of your injection body, the pressure will still be free flowing because we are pumping a fluid through the pores of the soil. And the good thing is that once you see the pump is rising up pressure, that is the same with cement. You know, okay, I have filled and my resin already reacted, so I have to stop. So either I have this cancellation criteria with the pressure or with the volume. If you are doing the displacement grouting, yes, of course, you will need a few bars, let's say maybe 20, 25, 30, to go into to push the resin into the soil. But after you did the first, let's say, 100 milliliter of resin into the soil, it starts to frack and build the roots, and then the resin flows. And then all the pressure which comes to the soil is done by expansion of the material. Also.
Yeah. And what's the behavior of this kind of materials against the lateral force? For example, we can build a wall with the thickness of 1 meter, 2 meter, in the depths of, for example, 10 meters, and then excavate this and build this wall as an end wall. Mm-hmm. Can we expect to resist against the lateral pressure?
The question is, so what kind of material you use, how big how big is the dimension of your wall which you create? But yes, so if you need, you can have 50 MPa or even more. Yeah. So it's in the end you can work with this like a normal supporting, like a normal shoring. So it's, but also if you're working in 10-meter depths, you might need some anchors. Yeah.
Any more questions?
So, it's a great presentation.
Hold on, Richie.
So first of all, it was a great presentations and a lot of question answers and all interesting questions and a lot of good explanations. One thing came up a couple of times in your talk, like the cost comparisons, like, you know, would you mind to give a brief idea, like when you are comparing a cost comparison, like per unit cost with your product versus a regular, say, other product?
So let's do it in two ways. What is the cost for I don't know 10 liters or 1 liter of cement grout? I don't know what it is here. Just give me a number.
About $40 for a 40 kilogram bag. $40.
Okay.
Buy and sell.
So $1 for 1 kg. Okay. And then we have 50 cents per liter of suspension. And you can assume that at least it's minimum 10 or 20 times higher. Now comes a but. What do you have also to calculate into your project budget? It's volume, it's also mobilization, demobilization, all the downtimes for the different businesses, depending on where your project is. It's also when you are injecting cement, how long do you have to wait? It's time, and time is money. You can do in this time, in this 28 days, you can do 3 other job sites. So you have, if you take into consideration all the parameters of your project and all the costs, then the injection method is not only comparable, then it's sometimes also cheaper. But this is also not our aim to be cheaper than the conventional methods, because they work. Yeah. I started my career also together in a construction company with Keller Foundation. They were in a joint venture with a company which I joined. So I know that these methods worked and that they are good, but they have limitations on the one or the other end. And with this polymer-based method, you can just widen your range of application which you can do. And if you have limitations which will be a kill criteria for your conventional methods, or which make it very, let's say, costly to do it like the conventional way, then this polymer grouting method can be really, really successful and also from cost point of view beneficial for you. But this is what we also give you. You will get an estimation. What I usually also write into my method statement is time consumption, for ramming the lenses, for the injection itself, for removal, for mobilization of a job site. But you may imagine that this mobilization of this job site doesn't take a lot of time. It's 1 hour, then it's done. But this I will always include in my statements, that how long do you need really? How long a team of 2 people, maybe 3, needs to be on job site and to do the grouting works.
Hi, it was a great presentation, very impressive. My question is related to, does this method, or have anybody have used this method for liquefaction mitigation?
For?
Liquefaction mitigation. Like, liquefaction mitigation.
Sorry, my English might be...
When earthquake happens,
soil become liquefied, like water flame. Right?
Now I understand. Liquidification.
Okay.
Actually, that is my topic. My master's thesis was about it.
That's good.
Yes, you can somehow do densification, but if you want to avoid liquidification of sandy soils, the best way is if you have free area, blast it.
Have anybody done any testing or anything, any kind of things like pre-post testing?
No.
Check whether how much
No.
strength gain or something like that? No.
No, it's this is a completely new idea, but I have to, once I'm back in Germany, I will go to the east of Germany because we have big coal mining over, trench coal mining over there, and they wanted to use these old coal mines for as lakes for leisure. But the problem is now when the cars drive and so on, they have vibrations, and weekly and monthly there were slopes going off and streets and complete trucks went down, and good idea.
Just a follow-up, how deep it can work, like how deep you can inject this one?
The resin itself, you can apply it, it's depending on the application methods. If you use this ram lens method, it's good for up to 15, maybe 16 meters, 17 meters in the depth. No, not 7-0, 1-7. Yeah. First of all, 7-0 makes no sense because your displacement will be like you are standing here and over there you inject. Second thing is it's strongly depending on the soil. We are ramming a small diameter steel pipe into it. First of all, we will get after certain depths a limitation because of friction. You can reduce it a little bit if you use some tricks. Second thing is that you cannot drill in the end. Yeah? So if you hit a stone, what you can do? Just pull it out and put it in again. So, or if you hit on the stone, you might cause a deflection. So you somehow have to really to think about after, usually I'd say after 12, 13 meters, I would think about if it's not a better idea to make a drill and to place a manchet tube or something. Yeah, so and then work with a double inflatable packer. Also for this type of application works. Or you use self-drilling anchors, also possible. Oh yes, this is our favorite application. We have done it a lot in Asia and still doing it. In Germany, in all our projects, in all our tunnel projects, we are there with our applicators and doing this type of injection. And usually also there we use a product which is a two-component polyurethane, or we have a two-component organomineral, which sounds strange, but it is silicate as an A component, isocyanate as a hardener. It's somehow a mixture, and both work depending on the situation. Especially the organomineral works also overhead. Therefore, they like it to fix the bolts when they do rock bolting, because it doesn't flow out of the drill hole.
Would you put your product in first and then drill the tieback, or you drill the tieback and then quickly try to seal the void with the water through the wall?
I would go the other way around. So I would inject after. Yeah. Okay. Thanks for all the questions.